Hi, we are going to talk in this video about solving rational inequalities. Rational inequality is an inequality that's going to contain rational expressions, and most of them will have a variable in the denominator. So we're going to take a look at rational inequalities where you have a single rational expression on one side, zero on the other side, and some sort of an inequality symbol between them. So what is the procedure we're going to follow? We're going to factor the numerator and denominator if possible. We're going to find real zeros of the denominator if any exist, and those are going to be excluded. Should say excluded values. The real zeros that make the denominator equal 0 also, those are real zeros of the rational expressions. Then we're going to mark all excluded values as open circle, mark real zeros on the same number line, and use the sign chart. In a way it is similar to solving polynomial inequalities, but there's one major difference there as far as excluded values. So let's take a look at this problem. So what do we have? Our excluded value here is going to be x does not equal 1. That comes from the denominator. What values make the numerator equal 0? So the numerator is going to be 0 when x equals 3 or when x equals -4. So all three numbers we're going to plot on the number line. So we can draw a number line. And we're going to plot our numbers, but it is very important that you remember that when you plot 1, it's an excluded value, and we have to keep it open because you cannot have you cannot use this value. Then we also have 3, and we also have -4. So these values are allowed, but we want to make sure it's greater than 0. So the next thing we are going to do is we're going to determine the signs. We're going to pick a number from each interval, plug it in, and see what sign we get. So if I pick a number here, let's say I pick -5. -5 minus 3 is negative. -5 minus plus 4 is negative. -5 minus 1 is negative. So we have negative over negative. That's going to give us negative sign. So we have a negative here. A number between -4 and 1. Let's pick 0. It can be any number here. 0 minus 3 is negative. 0 plus 4 is positive. 0 minus 1 is negative again. Oops, I'm sorry. Negative. So negative, positive. This is going to be a positive sign. A number between 1 and 3. 2 minus 3 is negative. 2 plus 4 is positive. 2 minus 1 is positive. 2 positives, 1 negative. We'll make it negative. And pick a number here. 4 minus 3 is positive, 4 plus 4 is positive, all positives here, and we're going to have positive sign. So we want it to be greater than 0, we're looking for positive. Strictly greater, we cannot use the endpoints. So the answer here will be from -4 open to 1, and then union, and we're going to go from 3 to infinity. So this is how you are going to approach all these problems. It's the same exact idea. Let's take a look at the next problem. So we have this expression here. So let's take a look at the numerator. In the numerator we know x is going to be 5, and also x equals -5/2. The denominator tells us that we cannot use -4. This is our excluded value. So we have three numbers. We're going to plot them on the number line. So the excluded value has to be open. That's going to be, let me use a different color here. So -4 will be here, open. Then we have -5/2, and we have 5. So in this case, we want it to be less than or equal to 0. Let's see what happens. So we pick a number here. Let's pick, for example, -5. 5 minus -5, that's positive. This one's going to be -10 plus 5, that's going to be negative. And -5 plus 4 is going to be negative as well. So this is actually going to give us a positive sign. Let's pick a number here. So let's see, this is 4, this is -5/2. So I think we should be good with -3. 5 minus -3 is positive. 2 times -3 plus 5, that's going to give us a negative still. The bottom is going to be positive now. -4, actually, let's see, -4, nope, -4. oh, when we have negative 3 plus 4, it's positive, right? So here we're going to have, let me see, here we're going to have a minus. So where did I go wrong? Let me see again. So 5 plus negative 3, that's positive. 2 times negative 3 is negative 6 plus 5 is negative. And on the bottom we have negative 3 plus 4, that's positive. Oh, that is negative. Everything's correct. The number here, let's use 0. 5 minus 0 is positive. This one's positive, and the bottom is positive, so we have all positives, and when you do this here, the sign is going to be negative. So here we want it to be less than or equal to 0. We are allowed to include the endpoints except the excluded values. So we're going to go from negative infinity to negative 4, which must be excluded because it's an excluded value. So negative infinity to negative 4, open. Does not matter if it's less than or equal to. Along with, and here, we're going to include both endpoints from negative 5 halves to 5. Okay. Next problem. So our 0 here is going to be x equals 6. Our excluded values, we cannot have negative 1 and we cannot have 2. Number line, plot the points. So let's see, the 2 points here will be excluded because they're open. So we're going to have what? We're going to have negative 1 here, we're going to have 2, and we're going to have 6. 6 does not have to be open. So how do the signs go here? Let's take a look. So let's pick a number. Here we pick negative 2. 6 minus negative 2 is positive. Negative 2 plus 1 is negative. 2 minus negative 2 is positive. The sign here is going to be minus. Between negative 1 and 2, let's use 0. 6 minus 0 is positive. 0 plus 1 is positive. 2 minus 0 is positive. All positive, we have positive. Continue applying that. You're going to see that it's going to be negative here, and it's going to be positive here. Usually signs alternate unless you have a double 0. We're going to see that. Okay? So we want to have something that's going to be greater than or equal to 0, but please remember, we cannot use the endpoints of this interval because they both excluded values. So even though it allows for that to equal 0, we cannot use these two numbers. So it's going to be open from negative 1 to 2, along with, and 6 we are good with, 6 closed to infinity. All right. Next example, so we have this problem here. So let's see, zeros are x equals negative 4 and x equals 6. Excluded values are x equals negative 1, cannot use negative 1, and x cannot equal 5. So we have 4 values that we're going to plot on our number line. Let's go ahead and do that. So we have negative, starting on the far left, we have negative 4, which is a good number. Then we have negative 1, which is an excluded value. So negative 4, negative 1. Then we have 5, which is also an excluded value. And we have 6, which is our 0. So same idea. I don't want to go through this process because it sometimes gets time consuming, but what you basically do is you pick a number from this interval, plug it in, and see what sign you're going to end up with. You don't care about the actual value that you're getting here, you just want to know what the sign is. Okay, I'm just going to do one. If I use negative 5, negative 5 plus 4 is negative, negative 5 minus 6 is negative, negative 5 plus 1 is negative, negative 5 minus 5 is negative. 4 negatives will give you plus. If you continue doing that, you're going to get minus and then plus again, then minus and then plus again. So you may have a question, does it always alternate? I already mentioned this. Well, we'll find out. So we want it to be greater than 0, strictly greater. So where is it greater than 0? It's going to be from negative infinity to negative 4, which is going to be open. Along with from negative 1 to 5. It's going to be open at both anyway. And also we're going to go from 6 to infinity, but 6 will be open because it's strictly greater. So we have this as our answer. Now let's take a look at this interesting problem that we have next. So here what happens is, well, first of all, we have to do a little bit more factoring. It's not completely factored. X squared minus 9 can be factored as x minus 3 times x plus 3. And then everything else we are going to copy. This square is fine, and then 2x plus 3, and we still want it to be less than or equal to 0. So 1, 2, 3 values that are going to be our zeros. We have x equals 3, we have x equals negative 3, and we have x equals negative 2. These are our zeros. On the bottom we cannot allow for x to equal negative 3 halves. Right, because then you're going to get 0. In the denominator we can't have this. Alright, our number line, plot all the points. Now we need to remember negative 3 halves is going to be open. So starting on the far left we have negative 3, this one's closed, negative 3, then we're going to have negative 2, which is also closed. Negative 3 halves, which is going to be open, it's our excluded value, and finally 3. Okay, so let's see how it's going to work here with the signs, because it's a little different here. So if I pick a point here, let's say I pick negative 4, this is negative, negative. Negative 4 plus 2 is negative, but when you square it, it's going to be positive. So we have negative times positive divided by the bottom with negative 4 will be negative as well. So our sign here will be 3 negatives will be negative. And we cross over negative 3. It's kind of tough to pick a value here, kind of in between. You don't have an integer that's going to be easy to work with. But let's think about this. You go with the number slightly greater than, well, greater than negative 3, but less than. Let's go ahead and try negative 2.5. So negative 2.5 minus 3 is negative, right? Negative 2.5 plus 3 is positive. This one's going to be positive all the time. We don't even have to test the sign there. And the bottom is going to be, the bottom is still going to remain negative. So negative, negative, positive, positive will give us plus. Let's pick a number here. When you pick a number here, you're going to end up with, so here when you cross over that, so number slightly greater than negative 2, this one's going to be negative, this one's going to be positive, the next one is positive, and the bottom is actually going to be negative again, so we are going to get a plus here again. And then this sign is going to be minus, this sign is going to be plus. Okay? The reason you do not have a sign change at negative 2 is because this is a double zero. That square makes it always positive, so whether you're on the left side of negative 2 or on the right side of negative 2, it's always going to remain positive. So in that case, you are not going to see a sign change there. That's why they don't alternate. We want it to be less than or equal to 0. So that means we want to be on the left of this. So it's going to be from negative infinity to negative 3. We are going to have it closed. No, hold on. Yeah, we can have it closed, right? Because this is not an excluded value. Then we're going to be from negative 3 halves, which is going to be open because it's an excluded value, to 3, and 3 is going to be closed because we are allowed to be at 3. So there you go. And also, here's a tricky thing. At negative 2, this function is actually going to, this expression is actually going to equal 0, and we allow for equality. So I'm also going to include 2 as just a single value. It's not a very common thing to see, but things like that sometimes happen. Alright, we got a couple more examples. So First thing we want to do in example 6 is factor. We'll try to figure out if it can be factored, and yes it can. The numerator, it can be factored as x minus 4 times x minus 1. The denominator is difference of squares, x minus 3 times x plus 3, greater than 0. So in the numerator, the numerator is going to be 0 when x is 4 or when x is 1. The denominator cannot allow for 0, so x cannot be 3 and x cannot be negative 3. These are our 4 values that we are going to plot on our number line. So let's see which one is the leftmost. Is going to be negative 3 and it's going to be open. Then we're going to have 1 that is going to be closed. Then it's going to be 3, and which is supposed to be open, I'm sorry, and then 4. Let's think about these together as far as the signs. When I'm going to be, this is an approach that you can take that might help you speed it up. When you pick a number here, like negative 4, you're going to have negative, 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 and negative. Everything's going to be negative. You are going to get a positive value. Okay. You do not have any double zeros here. Basically, any zero that has multiplicity of 2 or 4 is going to create a situation when the sign is not going to change, and it does not apply here. So you can safely go ahead and just alternate the signs here. We want to be greater than 0. So that means we're going to go from negative infinity to negative 3, which must be open. Then we're going to go from 1, which is going to be open anyway because it's strictly greater, to 3, which will be open anyway, it's an excluded value. And finally, we're going to go from 4 to infinity, and there we go. Okay, this last problem. So here is one situation that you have to address properly. X squared minus 7 is not actually going to be a difference of what you normally perceive as difference of squares, but you can still factor it with the real value. So you can factor x squared minus 7 as x minus square root of 7 times x plus square root of 7 times x plus 1. The denominator does not factor. This is not a factorable expression on real values. Not like this one. This one is not usually something that we factor, but it is something that can be factored on real values. X squared plus 16 does not have any real zeros, which means we have no excluded values. X can be any real number, but we do have 3 numbers that make the numerator 0. So it's going to be x equals square root of 7, x equals negative square root of 7, and x equals negative 1. No excluded values. Okay. So we draw a number line. Now, as far as the square root of 7, we should know the square root of 7 is 2 points something, just to have an idea where it's located. So negative square root of 7 will be here, and we don't have anything open. Negative 1 is going to be here, and square root of 7 is going to be somewhere here. And we do the same thing. We try the numbers. Please remember, the denominator here is always going to be positive. You don't even have to worry about that. The only thing you're really testing here is the numerator. Okay? So as far as the numerator, you just sign. So if you pick negative 3, that's going to be negative, negative, negative. 3 negatives will make it negative. If you pick a number here like negative 2, that's going to be negative, positive, negative. So it's going to be positive. Right here you can use 0. It's going to be negative, positive, positive. So negative, and then here it's going to be positive. We want it to be less than or equal to 0. So we're going to be from negative infinity to negative square root of 7, which I can include because less than or equal to. And also I'm going to go from negative 1 to square root of 7. So from negative 1 to square root of 7, both included. Okay, this is how it's done.